Hey everyone, in this video we are going to learn about Prim's algorithm, a famous greedy algorithm that helps us find the minimum spanning tree of a graph. I'll explain what Prim's algorithm is, why it is important and how it is works, using simple and easy to understand explanations. So, if you're learning data structure graph algorithms, this video will definitely help you. Let's get started. Prim's algorithm is a well-known greedy algorithm. It works by always choosing the edge with the smallest weighted at each step. It is mainly used to find the minimum spanning tree of a graph. That means it connects all the vertices together while keeping the total cost as low as possible. To use Prim's algorithm, the graph must be weighted, connected and undirected. Each edge should have a weight, all the vertex should be reachable, and the edges should not have any direction. Overall, Prim's algorithm helps us connect all nodes in the most efficient and cost-effective way. First, Prim's algorithm is used to find the minimum spanning tree or MST. This means it connects all the vertices in a graph while keeping the total edge weight as small as possible. Second, this algorithm works on a connected, weighted and undirected graph. Connected means every vertex can be reached. Weighted means each edge has a cost or value. And undirected means the edge have no direction. Finally, Prim's algorithm ensures that all vertices are connected with the minimum total edge weight. It does this by selecting the lowest cost edge at each step and avoiding cycle. So, first let's see how Prim's algorithm actually works. Here I have taken a simple graph to explain the concept clearly. We need to use a weighted graph because our goal is to find a minimum cost spanning tree. Now, as you already know, when we take a graph like this, it is possible to create multiple spanning trees from it. But instead of generating all possible spanning trees, this algorithm helps us find only the minimum cost spanning tree efficiently. In Prim's algorithm, we mainly focus on node and vertex. As you can see, this graph contains several nodes labeled A, B, C, and D. We divide all nodes into the two sets, visited and unvisited. Initially, the visited set is empty and all nodes are in the unvisited set. We can start from any node in the graph. It doesn't matter which vertex we choose first because it is a spanning tree. We eventually have to visit all vertices. Let's start from node A. We mark as a visited, which means A is removed from the unvisited set, A is added to the visited set. Next step, now we look at all the paths that connects visited node to unvisited nodes. At this moment, the visitor set contains only A. From node A, we can go to B, we can go to C, and we can go to D. Among these paths, we select the one with the minimum cost. You can see that the cost from A to B is 1, the cost from A to C and A to D is greater than 1. So, the node with the minimum cost edge is B. We now mark B as visited. Remove B from the unvisited set, added to B the visited set. Next iteration, now the visited set contains A and B. We again consider all edges from these visited node to see the unvisited node. From A to C, from A to D and from B to D. Among these edges, the minimum cost edge is from B to D. So, select D as the next node and mark it is visited. Final steps. Now the visited set contains A, B and D. The remaining unvisited node is C. We check the possible paths from A to C, from D to C. Between these two, the minimum cost path is from A to C. So we select the edge and mark C as visited. Result, at this point, the unvisited set is empty. all vertices have been visited. This means we have successfully constructed the minimum spanning tree using Prim's algorithm. If we can calculate the total cost of the selected edges, you can see that the overall cost of the minimum spanning tree is 7. Now let's find the minimum cost spanning tree for this graph. As usual, we divide node into the set visited and unvisited. At the beginning, all nodes are in the unvisited set. We can start from any node we like. Here, let's start with node D. We mark D as visited, which means D is removed from the unvisited set. D is added to the visited test. Next step. Now, we look at the path and edges that start from node D. Among these paths, one with the minimum cost is the edge from D to E, which has a cost of 10. So, we choose node E as the next node to visit. We now mark E is visited. Remove E from the unvisited test. Add to E is to visited set. Next iteration, at the point the visited set contains D and E. Now we consider all the edges that connect these visited node to the unvisited node. From D to C, from D to B, from E to B, and from E to C. Among all these paths, we select the edge with the minimum cost. Here, the minimum cost edge is from E to B, so we choose node B as the next node to visit the mark it has visited. We started by dividing the vertex of the graph into two sets, visited and unvisited set. Initially, all vertices are in the unvisited set. First, we select the starting vertex for example D and move into the visited set. Next, we look at all the edges that connected with vertex to unvisited vertex and choose the edge with the minimum cost. From the visited node B, the lowest cost edge connects B to A. So, we selected this edge, move and from the unvisited set to the visited set, and include the edge B minus A in the spanning tree. Now, we again examine all possible edges that connect the visited set of the unvisited set. At this stage, the only remaining unvisited vertex is C. Vertex C can be reached from the A, D, or E. Among these options, the edge with the minimum cost is the edge from A to C. So, we select this edge and move to C to the visited set. At this point, all the vertices have been visited and the unvisited set becomes empty. The selected edges together form the minimum cost spanning tree MST of the graph. This tree connects all vertices with the minimum possible total cost and without forming any cycles. Alright everyone, that brings us to the end of the today's session on Prim's algorithm. We decided how a minimum spanning tree is constructed using a greedy approach step by step. I hope this explanation helped you clearly understand how Prim's algorithm works in data structure and algorithm. If you found this video useful, don't forget to like, share and subscribe to the channel for more DSA tutorials and exam-oriented explanations. Thank you for watching and I will see you in the next video.